Welcome to the Environmental Transformation Podcast. I'm your host, Sean Grady, and today's guest is Jeffrey Rissman. He is the Senior Director of Industry at Energy Innovation, and he leads the company's work on technologies and policy to eliminate greenhouse gas emissions from the industry sector. He is also the author of Zero Carbon Industry, Transformative Technologies and Policies to Achieve a Sustainable Prosperity. And he's just released that new book. It's coming out, I think, next week? I think it's his official publication time, right?
That's right, February 27th, so
That,
Tuesday.
that's exciting. And Jeffrey also has been a co-author of Designing Climate Solutions, a policy guide for low carbon energy. That book was released in 2018. He's also the creator of the Energy Policy Simulator, and it's an open source computer model that quantifies the effects of various energy and environmental policies in combination with predicting outputs such as fuel usage, pollutant emissions, financial cost and savings, electrical vehicle deployment, power sector structure, and much more. So, Jeffrey, I'm really excited to talk to you. And the book was fantastic and very insightful. And let's dive in.
Sounds good, Sean. Thanks for having me on the show.
Absolutely. So congrats on the book. It's coming out on February 27th. So listeners, you can get access to it. Probably where can they get it? Get it on Amazon, or where's the best place to get it?
Yeah, so the best place to go is just zerocarbonindustry.com. From there, we have links to various stores, Amazon, Barnes & Noble, and Columbia University Press, where we also have a 20% off discount code for your listeners.
Ah, fantastic. So let's mention what the code is and we'll get that out to people. So the book outlines many ways that industry and society can achieve zero carbon. Is that really possible in the next 25, 30 years from now? Can we achieve a zero carbon industry by then?
Yes, it is possible. It won't happen simultaneously everywhere. Not every country will reach zero carbon industry at exactly the same moment. But so I give a bit of a range. I say 2050 to 2070 in the book to account for some differences depending on country and where their industry stands. But we have the technologies today that can cut industrial emissions enormously. And then we have technologies that been demonstrated or at various stages of R&D that are very promising that can take us the rest of the way within that 25 to 30 year time frame. Absolutely.
So for the listeners, let's just frame up what really do you mean by zero carbon industry so we can get that out of the way.
Sure. So industry here means the companies that make all of the materials and products we rely on, whether that's cement or steel or end use products like cars or a paperback book or personal electronics. Basically, the companies that make stuff. And collectively, the industrial sector is responsible for about a third of human caused greenhouse gas emissions. That includes the emissions from the electricity that industrial firms purchase. If you exclude that, it's about a quarter of emissions. Either way, it's an enormous share of our total emissions footprint. And that's why it's so important to look at how to accelerate this transition to clean industry.
Mm-hmm. Mm-hmm. Okay, that's good. To be zero carbon, we're basically saying what? There will be carbon emissions, but there's offsets or there's enough reduction in other areas. What's the true meaning behind zero carbon in that sense?
Yeah, I'm thinking of it as adding no net greenhouse gases to the atmosphere.
Okay.
And that includes carbon dioxide, but also other greenhouse gases like methane and nitrous oxide and fluorinated gases. The book doesn't focus on offsets. You could have offsets or you could try to remove emissions later with direct air capture. But I do think that there are technologies that can achieve zero emissions from industrial processes, whether that's electrifying industrial heat or using clean feedstocks, which are the inputs that they use to make chemicals. So it's really looking at how to cut industrial emissions down to zero. In practice, perhaps there will be some amount of offsets used at different points or by different countries. So that is a possibility.
That makes sense. Okay, to set the stage a bit to get a grasp of the magnitude of industrial emitters of greenhouse gas, What are the biggest countries that are the emitters in that space?
Sure. So, industrial emissions, it's interesting because of how concentrated they are. The number one emitter is China, which is responsible for 45% of global industrial greenhouse gas emissions,
Wow.
just almost half. And that's because of China's enormous manufacturing sector, which supplies products to countries around the world, including the US and Europe and elsewhere, as
Mhm.
well as the fact that China relies a lot on coal, which is a particularly emissions intensive fossil fuel. The other top emitting countries are India is the second highest with about 8%, and the United States with about 7%. Then if you group the European Union, they're at about 6% and would be in fourth place.
Mm.
So I tend to think of that four, that China, India, US, EU, as the most important regions in terms of industrial emissions.
Okay. All right. And then if we break down the emissions by specific industries, let's talk about which industries are the big emitters.
Yeah, so industrial emissions are also concentrated by industry. The biggest emitters are the iron and steel industry, the chemicals industry, which includes making chemical products like fertilizers or plastic resins, plastics, and then cement and concrete. Materials, essentially, that then go on to be made into products
Products.
and buildings later. But often the assembly of those materials into final products is less emissions intensive than making the materials in the first place.
Hmm. Hmm. So there's a lot of things I think that you spell out in the book, especially around technologies, policies, things like that that can really help drive this industry to a zero carbon industry. So let's talk a little bit about that. Right now, it seems like in the world that a lot of the policies have been aimed at more like consumers than it is the actual policies targeted towards industry. Why is that? And what can we do about that?
It's a great observation. I think there has been not enough focus by policymakers on industry, and there are a couple reasons for that. One is a question of two or three reasons. One is a question of visibility. In the transport sector, we see and use cars every day, and we get on planes, we physically interact with them. The electricity sector, we don't necessarily see the power plants every day, but we use electrical appliances all the time. And of course, our buildings, whether it's decarbonizing them with heat pumps or smart thermostats, good insulation, rooftop solar, these are very tangible things. Whereas people don't think as often about how cement is made, and they don't necessarily know what goes on there.
Hmm.
And that segues into sort of the second reason. Aside from visibility, there's a concern about complexity. Industrial firms make millions of sorts of products using countless production processes.
Hmm.
And so there's a worry a policymaker could have. How can I successfully use policies to or require change when I don't understand every production process at the level of an industrial engineer? And the last reason is concern about jobs or leakage. There's a worry that if you regulate industry, what if they were to move to a different jurisdiction to try to escape that regulation? Industry is a source of high quality jobs, and some industrial products are traded across regions or internationally. And so they don't want to do anything that would disadvantage industry in their area. Fortunately, all of these things can be overcome. And that's one reason why I wrote this book, to really highlight that, to cut through the complexity of industry and show how it can be successfully decarbonized in using technologies we understand today, and can be done in a way that grows the economy and creates new high quality jobs.
I think that's what everyone would like to see at some point, right? Because consumers now are seeing I guess, the policies of, say, for instance, in California, all new homes, and you have to have solar on your roofs and stuff. So that's a big impact to a residential homeowner, right? Oh, okay, now I have to incorporate that into my cost, which is usually a little more expensive, right? It's more expensive than a traditional roof. And you have to add that into and factor things in. And those are policies that I think are aimed at consumers where you don't really see it aimed at industry as much, right?
Yeah, there are certainly policies that focus on that and solutions for rooftop solar. For instance, they can, if you build it into the cost of the mortgage, the incremental mortgage payment on the value of the panels is less than the amount of money they'll save you in electricity bills. So you could save money from day one with those.
Hmm.
But again, you're right. That's a consumer oriented thing. And so that's why I think it's been important to focus instead now on some of the policies that can help incentivize industrial firms to switch to clean processes and create a fair and level playing field for clean industrial technology to help it flourish.
Yeah, no, I agree with you there. And I think that you really touch on a lot of these types of ideas in the book, which was fantastic. How can financial policies such as carbon pricing, green banks, subsidies, tax credits, rebates, those types of things, how can they help drive the industry to zero carbon emission?
Financial policies are really powerful and have a key role to play. And I think the ideal policy choice depends on the level of technological maturity of the technology you're looking to incentivize with the policy. For instance, direct financial incentives for clean industrial technology can make it more affordable for a firm to purchase and install new technology and do so with less disruption.
Hmm.
Another powerful financial policy that gives them confidence that there's a market for the products they would make is green public procurement. So that's where the government says, so governments are actually major purchasers of industrial products like steel and cement because they go into roads and public infrastructure and public buildings. So governments can say, look, let's set aside 5% of the steel we buy and make sure it comes from novel zero carbon primary steel sources. And then a steel maker knows that if they install a new hydrogen based steel making production facility, they have a market in which they can sell that steel. And when they do they scale up, it will drive down costs. They'll refine the production processes and government can ratchet up the share. Maybe it will purchase 10% and then 20% of its
Right.
steel. So that's a good way to create this starter market to help these technologies go down their learning curves. Carbon pricing, you mentioned, also has a role to play. I think it's actually a policy that's good for a little later in the technology life cycle, where let's say you have a commercialized clean technology and a commercialized dirty one. If there's a carbon price placed on the fuel used by the dirty technology, then industries are more likely when they next upgrade their equipment to choose to buy the clean version. And so the carbon price nudges that decision. If you use it before there's a clean technology option available, then industry will just pay the carbon price. And the ultimate goal of the carbon price policy isn't to have people pay the price, it's to have people decarbonize their processes instead of paying the price.
Right. Right.
So that's why it's a great fit once there are some commercialized clean options, which there are for some technologies today.
Sure. Sure. And I think that's really good. What about some of the non-financial policies, such as energy efficiency, emission standards, those types of disclosures, labeling? How can that help in this process too? Because that's another arrow in the quiver here.
Absolutely. Industry is a huge sector, and we need all of the arrows in the quiver that we have. So the so standards are very useful because there are some price barriers that can limit the effect of financial policies in some cases where some firms may not be very price sensitive or their consumers are not price sensitive and they're able to pass along costs or the like. Also other types of reasons why financial policies are not themselves sufficient all on their own. Standards can be very effective at, for example, removing the worst performing products from the market, which can help overcome some of these barriers, maybe information barriers, and ensure that everything achieves a minimum performance level. And by setting a standard that is based on what's available in the market, you can keep it updating automatically. For instance, let's say every 2 years, this new standard becomes, you take the median of all the commercialized sold products in the market, and that becomes the new standard for the following 2 years, maybe with a little lead time to
Hmm.
give industries a chance. This guarantees that products that can meet the standard are available for sale at commercial scale, because already half the products on the market meet the standard. And it guarantees the standard keeps getting tighter, which spurs innovation and makes it worthwhile for companies to invest in research and development.
That's really good. When I was looking and reading the book, these policy questions were coming to mind, and you've got these a situation where can you give us an example of, say, how policymakers concerned about the political opposition of you utilizing high visibility policies like well publicized subsidies to incentivize clean technology, and then also using like low visibility policies like standards, like we just talked about, these two types, rather than taxes to remove the worst performing technologies in the market.
That's another benefit of having a variety of policy types for different needs. There is a political angle to a lot of this. What type of policy can you enact in what region or country? Sometimes taxes and subsidies can be high visibility because they affect the price on things, and people will notice, even if it's an industrial firm purchasing machinery, they will compare what's available and typically will choose equipment that performs at a level that meets their needs, and and is reliable,
Mhm.
and is the lower cost option that meets those other criteria. Whereas a standard that removes a badly performing product from the market simply removes it from the decision space. You won't be comparing it to the others because it won't be available for sale. And that makes that type of policy often less visible. Standards are already widely used in the United States, in Europe, in China, in many countries to ensure that products are work well, are healthy, there are health and safety standards, as well as energy efficiency and emissions standards. So it's not a novel policy. It just involves applying the same policy, often by the same regulatory agencies, to sometimes new and different types of equipment. And that helps also to make it more politically feasible when it can often be handled by the same agency that may already have the power to do this.
So some of the types of technologies that we're like thinking about here that might be like the worst performing, is there any good example? Is like, yeah, we applied these policies to get them out of the market, essentially. Like, and this is how we did it.
So in the industry sector, we're still in early days with regard to policy. There are some examples. For instance, we're talking about standards here, standards that apply to industrial equipment. One example that comes to my mind is that the United States has efficiency standards on industrial electric motors. Those would be the motors that power industrial equipment like conveyor belts and pumps and fans and so on. And they're fairly detailed standards that consider properties of the motor, like its horsepower, and ensure that all these industrial motors, have a certain minimum level of efficiency. There are also standards on commercial boilers, which produce hot steam. And making steam is very important for industrial processes. The standards that exist today are set separately by fuel type. There'll be a standard for natural gas boilers and a standard for electric boilers, say. But a more powerful way to have standards is to make them technology and fuel neutral, so that because burning fuels is very energy inefficient, a lot of
Mm,
the energy is lost in the hot exhaust gases. So,
mhm.
switching to electricity is one of the ways that you can improve the efficiency of your equipment and thereby comply with the standards, if the standards are technology and fuel neutral.
Okay, that makes sense. Where do you see maybe venture capital jumping in to help boost and kickstart this transition? I don't think I saw that you really discussed it, but for me, and I just recently been doing some podcasts with a few VCs, they're at the forefront of the technology innovation space. And to me, that seems like it's got to be another piece of the puzzle here.
Absolutely. So, venture capital funds, or typically funds, early stage startups and companies that are trying to commercialize new technology. And increasingly, there are a wealth of these startups that are working on in clean industrial technology, which are the building blocks we need to decarbonize the industrial sector, particularly where we don't already have commercial solutions in place. Venture capital is one of the key funding sources for that type of startup, although not the only funding source. For instance, they can also get government funding, say
Right.
through, in the United States, the Department of Energy, the Advanced Research Projects Agency for Energy, also funds these types of innovative companies. I profile some of them in my book, for instance, in steel making. The most technologically mature way involves hydrogen, but there are also some ways to make primary steel directly from electricity using electricity to split iron ore into metallic iron and oxygen. Boston Metal and Electra are two companies that have different technologies that are attempting to do that. Or for thermal batteries, which is a technology that stores heat. You can obtain heat when electricity is cheap and then use it later in a facility when electricity is expensive instead of purchasing the electricity. A couple startups that work on that are Antora Energy and Rondo Energy. So there's it's a key part of the ecosystem, and I'm glad you highlighted it.
Yeah, I think hydrogen seems to be another one of the big leading carbon emission reduction type energy sources out there that is a lot of efforts going in, research is going into that. I'm familiar with a company called Lavo. They are creating hydrogen batteries, and that's pretty exciting what they're doing there with their company. A lot of this is evolving with these technologies. There's other ways that we're reducing emissions. And let's talk a little bit about from the recycling angle and creating a more robust infrastructure within society for a circular economy. How does that play into helping measure the success and generating product longevity, remanufacturing, and recycling to help reduce greenhouse gas emissions?
Circular economy is huge. One chapter of my book is devoted to these topics, which I think of in three sort of buckets: material efficiency, substitution of lower carbon materials, and then circular economy, which is about putting products to their highest and best use. To take them briefly, material efficiency is important because, as I mentioned near the beginning of the show, making materials like steel and cement is where a lot of the energy use and emissions are,
Hmm.
not in the assembly of the final products. So, if you can make the product with less material, but make it just as high quality, just as functional, then you can improve the consumer experience while cutting down on emissions and energy use, and quite possibly saving money as well.
Hmm.
Um,
Yeah, I think too, solving some of the recycling challenges that we're facing in society right now would be great, especially around plastics and then organic food waste and things like that. I mean, those are like recycling opportunities. Organic food waste, you can generate energy from that. Use a biodigester, and now we can create natural gas. That's huge. And I think not having enough of that type of infrastructure in place, we're losing out because we're just throwing stuff in the landfill right now, and it's creating it's creating landfill gas, but it's a whole nother discussion.
Absolutely. So yeah, jumping to recycling and the core of circular economy, you're absolutely right. So you can process organic waste with an anaerobic digester or other machinery and get biogas or biomethane that you can then use for energy, or you can even use it in chemical feedstocks to
Hmm.
make your plastics and fertilizers. And that's far better than letting it decay and letting that methane reach the atmosphere, since it's a powerful greenhouse gas.
Hmm.
And then for non-organics, you do want to try to avoid sending them to landfill. So the making products more durable and repairable is the first step, so that the product lasts longer. And if you're done with it, you can sell it or give it to someone else who can benefit from it. And then you don't have to make the steel and whatnot to make a replacement. You can also refurbish or remanufacture products, take them apart for pieces in some cases,
Yep.
and then recycling. If some cases you can't do those other things, let's say packaging, right? You've torn it open, you're not going to reuse the torn open packaging. Maybe the best option is recycling, but that still can avoid the production of new virgin materials.
Absolutely, 100%. One of the topics you did mention in the book, which was product longevity. I just want to touch on that a bit. If you think back, I'm old enough to think back in the 60s, 70s, products were made a little more durable, a little more solid. It had some like longevity to you reuse it more and more often. You just needed to fix it. And now I think we're in this fast food type quick disposable mindset of products, and we're not thinking just let's make something last longer.
That's true. There has been a trend toward less focus on making products durable and long lasting, and more focus on making them quickly and cheaply. I think we intuitively feel this when we purchase clothing, say, where
Yeah.
the one of the industries that has focused so more aggressively on cutting costs by sacrificing quality in many cases. And then personal electronics too sometimes cease to work very well or become obsolete quite soon, sooner than is truly necessary, or even the manufacturers may stop providing them with security updates, which
Mhm.
is another way to force people to upgrade even if the physical equipment is still working.
Yeah. I don't know how many times I've been caught in that little do loop. We need to upgrade because we no longer support that product. It's like, what?
Exactly.
There's nothing wrong with the product.
There are policies that can help. One type of policy I talk about is right to repair. Essentially, there are regulations or standards that give customers certain rights to repair their own products that they've purchased, that they own. And there are ways to do that. For instance, they can require companies to make diagnostic manuals or repair guides available for at least a certain number of years, or to make replacement parts available, or to use standard tools for the screws, let's say, that hold the product case closed.
Yeah.
They can use standard screw heads instead of a special proprietary type of screw that requires you to buy a new unique type of screwdriver to open it. Um,
We've been caught in that a few times too. I mean, geez Louise. One of
yeah.
the one of the things that I like, I'm an old stereo hi-fi guy. So if I'm looking for a vintage stereo piece of equipment, it's amazing how well built these older units were. And if you have a good technician, you can repair and restore a beautiful piece of hi-fi equipment that's, amazing, just as good, if not better than what they are today. And then that's that longevity, that's that manufacturing quality that was made back then, and it just takes a little bit to repair, and you still have good, if not better product that's out in the market today. And you're not buying another new piece of equipment, you're not consuming new raw materials, you're just reusing and managing your old stuff.
Absolutely. And I believe manufacturers still have the know how and capability to make that sort of high quality product today. They just need to have the right financial incentives and the right regulatory environment so that they choose to make products that last longer and provide more years of software updates or security updates, or use fasteners that can be opened or things like that
Mhm.
will help so it isn't lost forever. It's something we can and should do to help promote circular economy.
Sure, absolutely. What do you think is preventing industry from moving forward to address this need?
So, taking a step back and being more broadly about what's preventing industry from moving forward with clean industrial technologies, decarbonization, not just product longevity, I think there's two big pieces of the puzzle. One is the cost of electricity or other clean energy sources like clean hydrogen, and the other is the availability of industrial equipment that uses those clean energy sources. It's a bit of a chicken and egg problem because for there to be demand for the clean equipment, the energy cost has to be low enough. And for the energy to be useful, there has to be equipment that can use it. I think that the energy cost is the more fundamental one, because if companies see the financial case for manufacturing products cleanly, they will demand the equipment that can do that, and it can be quickly provided because the underlying technology is well understood.
Hmm.
Um, Electricity costs more per unit energy than fossil fuels today, and that's a challenge. But that comparison doesn't take into account the efficiency with which the energy is used. I mentioned earlier in the show that when you burn a fossil fuel, or hydrogen for that matter, you generate a lot of heat that escapes in the hot exhaust gases. And you also form water vapor, which leaves the system in the exhaust and carries energy out with it.
Hmm.
If you directly electrify industrial heating, you don't form exhaust gases, which means the heat stays in the industrial furnace or kiln or boiler or heat pump, and therefore more of the heat is used for what we care about, heating that product or material or driving a chemical reaction. That can help close the cost gap, especially with certain technologies. In other cases, there still is a cost gap even after accounting for efficiency. And that's where policies like the ones we discussed, the financial incentives, the green public procurement, the standards, can help level the playing field. And once you do that, it won't be very hard or take very long for equipment manufacturers to come out with electrified and clean versions of the equipment.
Yeah, no, that makes sense. I've always been intrigued by the concept of clean energy, especially around solar. To me, that's probably one of the areas that we could expedite greenhouse gas emission reductions by deploying solar literally on every house in our country. Think about it. If solar panels were so affordable, you could just go to Home Depot or Lowe's or wherever and figure out the size of your home, quickly do a chart assessment of the energy consumption you have, and it's completely plug and play. And you don't really need an electrician because you're just plugging together panel and circuit connectors. And as long as there's one of the connectors set up on your utility box, I don't know why we can't get there, but I think the biggest challenge that I've seen if I've had this conversation with people is that really our utility infrastructure isn't prepared to be a storage system. They're only for set up right now for really truly distribution of electricity. And if all that energy was coming in, because there's going to be so much of it, you've got either battery storage or selling it back to the grid. I don't think our system in our country is ready for all that energy that we would generate. And it's like, how do we move into that direction so that we can make it so simple that a caveman can put the darn panels on their home and plug and play? Come on. So maybe I'm wrong, but I'm thinking there's got to be something here.
I think you're right that we need much more deployment of renewable electricity generation, including solar on roofs. And the book has some estimates actually on how much more electricity will be needed to decarbonize industry. And it's a lot. But fortunately, it's increasingly affordable to do this. I think so. Solar prices have plummeted in the past 10 years and 5 years, and as have battery prices for that matter, and are now far more affordable than ever. They can save money from day one if they are priced into a mortgage or if you get financing for them and use the electricity savings to cover that payment, or they can be purchased up front. They do require some installation work, but I don't think that's like the key barrier. There are also now rules about on the grid of how much you're compensated for them, and it can be different if you have battery storage because
Mhm,
batteries may let you use more of the energy yourself rather than selling it back to the grid,
mhm.
and that allows you to avoid buying the electricity at retail rates instead of accepting whatever payment the utility offers.
Yep.
So in some states, based on this is done state by state with public utility commissions. In some states, they don't pay very well for electricity sold back to the grid from
Yeah.
solar panels. And in places like that, batteries provide a good solution because they enable the homeowner to avoid purchasing the expensive electricity instead of having to accept the lower payment when selling their own electricity back to the
Mhm,
grid.
mhm. I
Uh,
just think that could be because we know that the building environment within our society is like what, a third of the greenhouse gas emissions that, because we're consuming the energy to heat the buildings. And if we were generating energy, it would offset that completely, right?
Yeah, if you allocate the emissions from the purchased electricity to each sector, building sector is huge. I think it is approaching a third, a little less, but it's
It's
enormous.
significant. Yeah, it's
Yeah,
significant.
as is industry, which is the book's focus. Both are important and both require electricity, hence the need for more solar, just as you were saying, as well as other clean electricity sources.
Good discussion there, Jeff. Let's talk a little bit about how do you see technology helping industry achieve net zero or zero carbon by say 2050 or 2060?
Sure.
How's that going to happen?
So there are so many exciting technologies now that can help industry produce products cleanly and efficiently. The book spends quite a few chapters detailing them, so I won't be able to discuss them all here. We'll direct viewers to where to get the book.
Yeah.
I think iron and steel making, I mentioned there's hydrogen based steel. It's called hydrogen direct reduced iron, is a way to use electricity to split water into hydrogen and oxygen and then use that clean hydrogen to make the steel. In cement and concrete, there are new cement chemistries that require lower heat to make the cement and also emit less carbon dioxide when breaking down the minerals that form the cement. There are energy efficiency technologies or electrification. Some of my favorites are actually about providing industrial heat directly from electricity. I already mentioned thermal batteries earlier that store heat by purchasing electricity in hours when it is cheap and letting the industry avoid purchasing it in hours when it's expensive.
Mhm.
They can output heat at up to 15 or 1700 degrees Celsius, which is enough for almost any industrial process. Heat pumps are one more I'll name because I find them very exciting. Heat pumps are most familiar in the building sector context where they may provide heating and cooling for your home or
Mhm.
your water heater. But there are also industrial models that can output heat at temperatures up to 165 Celsius or so, more than enough to boil water, hot enough for about a third of industrial heating needs that are currently met with combustible fuels. Things like the food industry, which is cooking and packaging food, or textiles, or forming products out of purchased metal and surface finishing, like heat treating the parts. There's lots of things you can do with heat from heat pumps. And heat pumps are super efficient because
Mhm.
they move heat rather than create it. They can produce between 2 and 5 times more usable heat than the energy content of the electricity you put into them.
Mm.
No other technology can rival them in terms of that level of efficiency.
Wow, that's impressive. Yeah, I didn't know that. That's impressive. Well, where's carbon capture fit into these discussions? I think that's a new hot topic.
Yeah, so I also cover carbon capture in my book. Carbon capture has its niche, it has its pluses and minuses. Carbon capture means taking carbon dioxide from an industrial process or whether it's fossil fuel combustion or some non combustion process, compressing it, piping it, and storing it underground. Today, it's often done to help produce more fossil fuels through enhanced oil recovery or enhanced gas recovery. But if you use it that way, you're not helping the climate. If you store the carbon dioxide in dedicated storage, not associated with fossil fuel production, that has a role to play, particularly for the cement sector. I mentioned that cement is made from minerals. You heat the minerals in a kiln or a precalciner, which breaks them down chemically. The main mineral used today is limestone, also a calcium carbonate, and a type of rock that has carbon in it. And when you break it down with heat, some of the carbon comes out and is emitted as CO2. So even if you use electricity to heat the cement kiln and you don't burn fossil fuels, you'll still have about 60% of the CO2 emissions that cement does today, which is the share that comes from breaking down minerals.
Mhm.
If you use carbon capture for those, you won't have to separate it from exhaust gases like atmospheric nitrogen or oxygen because you weren't burning anything. You used electricity to heat the kiln. So you have a relatively pure source of CO2, making capture easier, and then you can put it underground to safely store it. It is one of the best options for dealing with these process non combustion emissions from cement. And there may be a role for it for other non combustion emissions. When using it for combustion, there are other concerns. For instance, it doesn't address upstream emissions. So if you're still extracting natural gas from natural gas fields, some of that will leak as methane and get into the air, even if you capture carbon from the methane you burn in the factory.
Huh.
A nuanced topic, and I do believe there's a niche for it, but it
There's a
has to be
place.
done carefully.
Yeah, it sounds like it's a good alternative or a good place to help minimize some of the greenhouse gases, but it's got its use cases that are specific. I usually do a little bit of a lightning round with the guest, and so here we go. What technologies or sectors do you see that will make the biggest impact achieving zero carbon?
Sector wise, industry, transport, electric power, and buildings are the big four. That covers a huge share of the economy. There's also land use and agriculture, and waste wraps up the rest. But I would say they all have a big role to play. And the one that I think needs more attention is industry.
Hmm.
As
Okay.
far as the technologies, I think the lowest hanging fruit and the ones that should be focused on first are electrification of industrial heating, along with energy efficiency and material efficiency and circular economy. But you can't get all the energy you need from energy efficiency and material efficiency. You'll still need some energy to produce your goods. And electricity is one of the most efficient ways to do that.
Excellent. No, that's good. Can government actually create the policies needed to help make zero carbon industry a reality?
Absolutely. Government can and they must. In order for us to reach our climate targets, numerous countries have already committed to reaching net zero greenhouse gases. The EU has set a 2050 target, as has the United States. China has said they're going to be net zero by 2060. This is also what scientists say is necessary to protect the climate and stop harms like wildfires, sea level rise, and hurricanes that are already doing damage and stand to get worse as climate change continues.
Okay, and I agree with you there. We're basically 25 years out, essentially. Are we doing enough now to get there fast enough? I think I'm starting to feel like we're not doing enough now. And who's going to be able to lay down the hammer on industry to fix it?
We're not on track right now. You're absolutely right. And emissions are still high or increasing globally. And we've had the hottest year on record was last year, and that's continued through this January. It is an urgent problem. The and governments have to be the ones to step up and create the incentives that are needed to accelerate adoption of the technologies we have today that can enable clean industry as well as cleaning up the other sectors and can make it financially profitable to do so and secure technological leadership, not to mention other important benefits like public health. It's worth remembering that thousands of Americans die every year from the pollution from burning fossil fuels and also in other countries like China and India and elsewhere. So there's huge benefits to be had through the public policy that accelerates these transitions.
I just fear or have concerns that with the various political parties in power, they're not taking it serious enough. And really it's irrespective of what party you're affiliated with, in my opinion, because it's always a logger jam in the Congress, or it's a sad story, to be honest with you. But will industry embrace this concept and help create a more sustainable world through achieving zero carbon emissions? Will they do it because they're motivated by the bottom line?
That's right. And I think that industry, so remember, industry are the folks that produce all of the solar panels, all of the wind turbines, all the electric vehicles and the batteries. They produce all the technologies we will need to decarbonize every sector of the economy, including industry themselves. They have the opportunity and the responsibility to be the heroes in this story.
Hmm.
And industry is not monolithic. Not every company will embrace this at all at the same moment. But they all do respond to public policy. They care about financial incentives, they care about standards. This defines the landscape in which they operate and how they make money.
Yeah.
So that's why my book puts public policy in the driver's seat. It shows that we have technologies to do this. Here's what they are. But we need public policy to create that landscape that rewards investment and technological leadership and makes and values it so that industries make the switch.
Yeah, no, I agree with you there. And it's interesting. A lot of companies are pledging zero net carbon by 2050 and which is commendable, especially some of these larger oil and gas companies. Their executives now are being compensated by meeting ESG goals versus production goals. That's unheard of. We've never seen that before. And then also you've got a lot of investors that are putting a lot of pressure on companies now to really ramp up their sustainability programs because they want to invest in companies that are basically walking the talk. Right? And I think that there's a lot of consumers right now, especially that Gen Z and some of the millennials these days, that man, they are willing to pay the extra price for the product they want that meets their personal mission on becoming more living in a more sustainable society too. So I think that's a big change and a shift, but I'm just concerned that we're still lagging, right? We're still not getting there fast enough.
More definitely needs to be done. We as a society do get to decide what we value and what we place value on, and that's implemented often through public policy as well as through personal choices. People care about a whole plethora of things. People do not always purchase the cheapest version of everything. If you're buying a car, some people prefer expensive or luxury brands. If they didn't, there would be no luxury brands. The only cars would be the cheapest possible ones.
Yeah.
And it's just an example to illustrate that people have all value all kinds of things, and having a product that was made in a way that doesn't destroy the climate, that isn't harmful to people and the environment, is something that many people value and many companies value with their corporate purchasing agreements, which are becoming much more common, and even governments. A good example is the European Union, where they have a carbon border adjustment now, so that if you're trying to sell products into the European Union and they were made in a very dirty way, there will be a tax on that product so that you can't get a financial advantage by making the product in a way that is harmful to people and the planet.
That's great. And I think another example that I've seen recently, or not recently, but I know of, is like people like, say, Walmart. They're pushing sustainability policies down to their suppliers. Like, show me your sustainability goals and your performance because we're going to be buying from these types of suppliers and not people who are really not trying to, pull in the same direction we are as a company. And I think that's great. It's being pushed down. So I think I've got hope that we're going in the right direction. And Jeffrey, your book is amazing. Literally, the discussion around here's the policy, and for example, here's what it means. For the layman to really get this, people need to understand, connect the dots. Like you spell it out, but you got to connect the dots and give an example. And I think you did a really good job of that in the book, in a lot of areas of the book. And it really was more impactful for me when I was reading it. And kudos to you in this book. I could tell you spent a lot of time and a lot of thought putting that book together. Kudos to you.
Yeah.
It's a good book. And I'm going to spend more time with it myself because I'd highly recommend anybody that's listening, zero carbon emissions. This book is really impressive. And it's a great read. So, thanks for coming onto the show. I guess one question I have left for you is how do people get a hold of you and get a copy of the book?
Absolutely, Sean. And thanks. It was a huge project, 4 years, really, start to end, of intensive research and writing and creating data graphics that the book is filled with. I work at a nonpartisan energy and climate policy think tank, Energy Innovation. They can get in touch with me there. Contact info is at energyinnovation.org. And the book has its own website. And the best way to get the book is to go to zerocarbonindustry.com. At zerocarbonindustry.com, there are links to a variety of stores you can buy the book. and a 20% off discount code if you buy it from Columbia University Press is on the site there. And it comes out on February 27th, but it's already shipping now from some retailers.
That's great. And we'll give a copy away to a lucky listener who's listening, and send out a little message to first person who buys me a cup of coffee on the website. So you just go to my website at seankgrady.com, buy a cup of coffee, and you first person to do it, you'll get a free book. So great way to get this out to the masses. Jeffrey, thank you for coming onto the show. Fantastic book. Kudos again. Looking forward to seeing some positive reviews come out. So it's going to be fun.
Thank you so much, Sean, for having me and having this high quality discussion. I can't wait to get this information into your listeners' hands and to policymakers and everywhere it can make a difference.
Absolutely.